Alright, this time we're going to work out the volume of a pyramid. And we're going to start this with a square pyramid. We're going to use the square pyramid to find a pattern. And we'll see after that that this pattern applies to all types of pyramids. So even though we start with a square one, it actually applies to all types of pyramids. Okay? So we're going to wrap this square pyramid inside a cube that just surrounds it. And then we're going to shrink this pyramid down to half its size. And so that way, the tip of the pyramid sits right in the middle of the cube. And if we start sort of rotating this pyramid, we see that we can actually fill up the inside of the cube with copies of the pyramid. And if we watch that closely, we'll see that it actually took 6 pyramids, one for each face of the cube. And so 6 of these sort of half-size pyramids make up the entire cube. Which means if we take the original pyramid and stretch it back up to the full size, it would take exactly 3 of them to fill up the cube. Okay, and so the pattern seems to be that the pyramid is 1/3 of the size of a prism that just surrounds it, that just wraps around it. Okay, but how do we know that this pattern applies to other shapes, not just to square pyramids or cubes? Right, so given any other pyramid, so say even this cone here, we could imagine a square pyramid made with the same base area and the same height as the cone. We can imagine constructing that pyramid. Then if we break up the square pyramid into cross sections, we've done similar things before, I think, with the sphere and stuff. We can argue by proportion that each of these cross section slices actually corresponds to an equally sized cross section slice on our cone, even though it's a circle and we're going from squares to circles, but they would be the same because it's all proportional. Right. So actually, the cone would have the same total volume then as the square pyramid. And so any pattern, anything we discovered about the square pyramid applies equally to any other shape as well, so cones or other types of pyramids. Okay, now the details of this, I'll leave a link in the description. It's called Cavalieri's principle, but that's only if you're really interested. Okay, so the pattern we discovered earlier applies, and here's what you need to take away from all this. It's that the volume of any pyramid is 1/3 of the volume of the prism that just surrounds it. So the prism with the same base shape and the same height. Okay, and so if you want a formula for that, then the volume would be 1/3 times the area of the base times how tall the pyramid is. So we'll go through a bit of a different example this time. It comes from a paper a couple of years ago, and the difference is it uses some algebra, not just numbers. Thought we'd try that for a change. And we're asked to find a simplified expression for the volume of this pyramid. Now the volume is always 1/3 times the area of the base shape times the height of the pyramid. That's the height from the tip straight down to the bottom. So for us, it's going to be 1/3 times, well, the base is some sort of rectangle whose length is 4x and whose width is 3x. So the area there would be 4x times 3x. Then we have the height, which we're given is 2x from the tip straight down to the bottom. And so we better multiply that by 2x. And I think the simplest way to clean that up is to see that the 1/3 will cancel with the 3, giving you 4 times 2 is 8 and 3 copies of x multiplying together. Okay, so that would be the volume. But the volume of any pyramid, no matter what that bottom shape is, should be 1/3 times the area of that bottom shape, whether it's a square or a triangle or a circle even for a cone, multiplied by the height of the pyramid from the tip straight down to the bottom. Okay, so like for the prisms and stuff, you need to know your 2D areas. Like for a circle, it'd be pi r square and all those other ones in order to work out these volumes. Okay, but it's always 1/3 times the area of that base shape times how tall the pyramid is. Okay, so that's all. Thanks for watching, and I'll see you later.